Hello, this is a new tutorial which is a little more complicated, but it will give you some insights. It's not that you have to do it, but you have to get this understanding. I think it's very important for you as an architect. So the idea is that you do your modeling of the design elements in Blender. So you go with all these edits in Blender. Then you transfer these things to the lambda calculus in Mathematica to play these elements on stage with code in a very flexible way, and then bring that back to Blender for the sophisticated rendering not developed in, not provided in Mathematica. So the idea is that you get an understanding that if you are thinking architecture in this abstract way, all these environments, Blender, Python, Mathematica, or conventional CAD systems, they are just hosting your conception of, and you're able to migrate between different environments and keep the consistency of your architectural model, because the model is do not stick to a certain geometry, to a certain structure, to a certain syntax, and so on. It's completely abstracted from that. This is what coding is about. So, to give you an impression how this works, I think it's good to follow this. If you want to go in this direction, all these files are available, and there will be more on this if you're interested. So this is what we want to do. We distinguish between architectural model and the object design. This will be later. Our architectural model should be very simple. It's just the sketch of a component-based building. So we want to have modular modules organized in space. We assume a certain grid. If this is 0, 3, 6, 0, 3, 6, then we put in here our module, and we want to have that module A, and we want to have that again here, and here again. Here, there should be a column, and this is our architectural model, just to get the idea of how to organize things. So this is your sketch. Completely different from that. This is what we want to do in Mathematica. And we want to do that as code, because the hypothesis is that the most adequate way how to articulate an architectural model is code, whatever it is. So, in strict contrast to that, we have the object design. So this is not code, this is CAD. So what do we have? We want to have a ceiling. It's on the grid. Insertion point should be at 0. We want to have the column. So this is ceiling, this is a column, this should be of light gray, this should be of dark gray. So this whole thing should be module A. Then we want to have this thing on level of detail 1, which is a sketchy one, just to prove the principal concepts in layout. And if we then have a proof of the spatial organization, then we can go in detail of the design, and then we do the same thing, module A, but in level of detail 2, 3, 4, whatever you like, or in different alternatives, and so on. So here we want to do, we need the same geometry. So, but let's refine our, make round edges and refine our design, something like that. Take the same names, but LOD2 instead of LOD1. So this is cat, and we want to do that in the edit mode of Blender. And we want to use the group layers, grouping, the hierarchies, and so on to organize our library. So this object design should be library 01.blender. So this here then refers to this library and puts instances of these modules into space in Mathematica, and then we want to go back for rendering in Blender. This is what we want to do. So let's start. First, you want to build the library in object design with Blender. So we open Blender. Okay, then we need our directory for our project. We need to include this Mathematica to Blender and MTP code Python. This is delivered and you can download it from GitHub. So our projects and our library should be in this directory. So now we simply create our cube for the ceiling. So this is not too important, this is a ceiling, but with our the meshes, this is a database we are referring to, ceiling, and we say it's LOD1. Make an underscore, ceiling LOD1. That's the first element. That's the name and the reference in the database. Now go to, I want to show you what I'm doing. Now go to edit mode. The insertion point should be 000. Now we scale the whole thing in by 0.1. And scale it 0.1, and it should be 1 in X and Y, so this is here. Then make it 0.5. So that's a proper ceiling. Then to get a nice gap between the modules, I think it's good to have it 0.95 in X and Y. So that's it. Good, but we have to move it up 1-2 units. That's good. And it should be not 2 meters, but half of the depth of the ceiling, which is 0.1 unit, 10 centimeters. So you have to put it down by 0.05. So which is 1.95 meters up. So that's our ceiling in LOD 1. 2 by 2 meters, that's it. So indifferent to our sketch, we had 3 meters, now we make 2 meters. So now add the column. We again call that the column. And it's important to have it here, column underscore LOD1. So this should be 10 centimeters in diameter as well. So we go to the edit mode. So now we are in the design of things. Scale it by 0.05. And then say in Z direction it should be 1. X and Y it should be scaled. And then move it up 1 unit. So that's it. And the problem here is that we get confusion here, so we have to move the top vertices a little down by 5 centimeters, for example. So which means deselect all, select them, and move them down by minus 0.015. So there we are in the middle. Leave that. That's good. So we have ceiling LOD, column LOD 1. We organize that on layer 1 for LOD 1 so that we keep overview in our library. So that's fine. Now the materials. This one should be dark gray, so we create a new material, and this should be dark gray, dark gray, and we can render it, and this one should be then we copy the dark gray and we say this is light gray. You have to be very careful not to have spelling mistakes, because this is how to match between the different environments just by the precision in these names. So light gray should be something like that. Good, keep that as standard. So we have our library of meshes and our library of materials. This is all level of detail 1. We organize it on level 1. Level 2 will be later, layer 2 will be later for level of detail 2. So these two elements, they should be in part of module A, because we want to take them as a group. So we can do it here as group objects, and then import that, or we can do it later with Mathematica. So in our case we want to do it in Mathematica and to give a better introduction. But we can do it here and then import it directly as a module in Mathematica. So this is our library 01, and therefore we have to save the whole thing. A4, and we say library 01.blend. Save as the Blender file in A47. Save it. That's it with Blender. Now we check the whole thing. This is our library. Very small, it's 500 kilobytes. That's it. Good. Now go to Mathematica to Blender. Here we have an wrapping of the Python commands we'd seen, and our example now is an exact copy of this metaphor of stage play, architecture model as a stage play. As we implemented it in Python, we found it very useful, and of course you have the freedom of all the lambda calculus or any programming language to modify it as you like. But with these stage plays we are good for the beginning, and now we have an exact copy of that to give you an impression that these ideas of how to model in code is up to you, and it's not fixed to a certain structure or to a certain geometry. Code is an abstraction from that. It's a language, a new way to talk, and you can do it in prosa or poetry or whatever you like. And now we are writing a drama on stage, and for that we have a certain way to organize our things just with actors on stage, to have an idea how to do that. So this file in Mathematica, which you can start with, is preventing, so there are a lot of functions here. So they are simply wrapping Python code. So there is a Python code, it's called create block, in a certain scene with a building at a certain location, certain rotation, a certain layer. So there is a similar thing here now in Mathematica. We say it's Blender create block. We have the same sequence of parameters, but because it's Mathematica, it has another syntax. So you see these are round brackets, and there are square brackets, and we have these curly brackets, and here round. Then the strings are differently, and so on. So the translation of this Mathematica syntax to Python syntax is done with this function. So which means if I put it here, take this here and evaluate the whole gray areas, and then evaluate this element, then my Mathematica command is translated to Python. And we did it with all the commands for materials, for meshes, how to create meshes, how to import meshes, object, and so on, and for groups, inheritance, arrangements, and so on, as we discussed in the prior tutorials. And therefore, now our Mathematica code for our example is structured the same way like Python, exactly the same structure, but it's just for didactical reasons. So, to make our architectural model as a stage play, we follow this scheme here and modify that. So our directory is proper here, but we need a backslash here. 47 is our directory. So then we want to create two layers, one for the prototypes and one for the actual assembly and architecture. So this is layer O, this is layer 1. Our library should be library O1 in this directory, and we call that library. So this is standard. We just give the Python code this directory where to look up the library and look up the Python code and so on. Now we are working with the outline. Now let's have a better look. This is old. Good. So the outline describes what should happen here. So we want to, in a new document, we don't take the library object. We want to have the scene, which is always the top hierarchy, the root of all things. We want to have the prototype, subdirectory prototypes on layer P, which is O. Then we also want to have building A as a child of scene. This is at location OO, rotation OO, but on layer A, which means it's for the assembly. So then, child of building A should be floor 1 and floor 2. Floor 2 is 3 elements, let's do it 2 elements in Z in our case, but the rest is the same. So this is our outline, we want to have it here. The materials now. We don't want to create simple materials, we already have it in the material, so we can import materials from library, and we had that dark gray. be very sure that this is what we had. If you're not, copy that. For example, start with light gray, and dark gray. So these materials we want to have imported, and these are the two. The same with the meshes. So go to this library of the meshes and say we want to copy this, and go here and we want to import this, and we want to import the column LOD01 from the same library. We can have as many libraries as we like. So now we want to create a module. This is what we what we can do in Blender and predefine in Blender with groups. There's a tutorial for that. Now we're doing it by code in Mathematica. So the scheme, we say it's module A, and then we create create a group object. There's another command available, group object, and then this is simply a combination of these two commands. So this is a group object. It is the column 01. We say the column should be dark gray. Copy. It should be this is the call. It should be column LOD1, dark gray. It should be on prototypes at the insertion point 00, rotation 00 on layer prototypes. And it should be element of module A. So we do the same thing with this ceiling. Then be very careful with, so just copy and paste it. It's better than writing it. If you have a mistake, then always mismatch. It's very bad in this rough environments. It's very bad in debugging your stuff. This is light gray. Should be prototypes, the same thing, because the ceiling is properly to the same insertion point like the column, so you don't have to take care here. Layer P, module A as well. So this is our module. So then the assembly, we can skip this, and this is a scheme how to insert an instance of a group, which is here, module A. So we insert module A, we give that a name. So for example, we say this is module 01 underscore 01. This should be on floor 01. This is a parent. 0, 0, 0, 0, no rotation, but now on the assembly layer, not on the prototype layer. So now we put multiple of them. So take 5. Floor 1. So on all this we put the numbers. We can keep, if we don't want to refer to that, the numbering will be done automatically, but now we force it to if we have unique names here, we force it to these names, and we can refer to it. If we don't do it, there's an automatic numbering with this 001, 0013, 14, 15. But then you don't know which elements have which name. This is it. If you have a unique thing, you get a unique name, and then you can refer to it. So all this should be on floor 1. But the first is, we don't want to rotate the whole story, but the first is on floor 1, which means it's on 0 here. We want to have this here. We want to this here 2 in X, this 4 in x, this 2 in y, and this 4 in y. So this is layer 1, and if we want to have, for example, then another series, can do the same thing, but we can put that on floor number 2, and then it's the same, and because it's floor 2 and floor is up 2, we can keep the same coordinates, but skip these remote things. So this is our architectural model. So you see now it's a kind of patch field, very clear where these numbers and so on and these organizations are. And you see that this is a kind of predefinition, the scheme and the principal setup, and this is your actual assembly. And because you have these redundancies, and you can write programs and nice code for it to make it more compact. So parameterize it, make a grammar for that, whatever you like. So don't think this will be this kind of redundancy. Prevent that. This can be done more adequate to a design and imitate your idea. So we save that at our directory, which is this one, which is correct, and give it our, we say this is layout 1 Python. We give this is a code, we gave that, and save that as text. So now our Mathematica code is translated to Python code, which is very compact and saved in this file. So that was the next chapter. Now we look it up in Python. So we have it here. That's our code. And now we create a new document in Python. And we go to the text editor and load this thing. So this is our layout 01. And here we have the generated code. Python code. If we run that, you see what happens here. We just have our prototypes. There's a prototype ceiling and column. We have the ceiling LOD1, column LOD1. In the building we have floor 1, the modules, floor 2, the modules as we designed that. And now if we look it up in our 3D view, this is our imported prototype on layer O. This is layer P, the prototype layer, and this was our assembly layer. So we had these 5 elements on floor 01 and the 2 elements on floor 02. This is how it works. Now the next chapter, if we want to improve or change the structure, we very easily, we don't have to touch it in here with these things. Or let's look at whether the material is working. Yes, you see the materials are working. So if we go here, we see that, go for the prototypes, ceiling, and then you see we have these, it's redundant. So we have these two materials from the database, and we have these 2 objects from the database, and the rest is structured somehow. We see that, for example, this ceiling here, if we see with the groups, it's of module A, and we have the visibility of that, and so on, as we did. So all this is done now in this nice patch field here, in this code. So now, for example, if we want to have another layer, we, for example, can say the assembly of floor 1 should be on this, and it should be on 3. And the layer, so this is A1, this is floor 2. So then you say The floor 2 should be on layer 2, and if I want to see both layers, I can have it on 3, which is kind of silly because you can select both. But just to show you the strength of it. Therefore, we go for A, and we say building should be on level A, floor 1 should be here, that should be on A2. Then, if we go here, we say on floor 2, these 3 should be on 2, and these should be on 1. So, as I told you, if you put there a certain grammar, then you don't have these redundancies. So, the principal setup here is on the prototype level. We didn't change that. So, if we export that again now, then we can go create a complete new setup, and what you have is we simply don't care about the graphics any longer. We care about our code, which means the code is always unfolding to a graphics. So therefore it's always error-free because it's a kind of production of the thing. So therefore we skip that, we don't need that. So get a new one and import the code again. This can be done automatically, so then you have it like this, but then you will not understand. So it's layout in a modified way, and run it. We now go to our 3D view. Now we have all these layers here. Now we have the first layer, the second layer, and combined layers. Good. Now, just to show you the performance of that, now we want to go and look for the level of detail 2. So we open the library. We copy, we duplicate this and move that to the next layer. So our convention is that this is level of detail 1, these are the objects of level of detail 2. Therefore, we have to check it. So this is ceiling 01, it's a copy of ceiling. We can change the names here, but this is not important. The important thing is that by copying and not a duplicated link, we duplicated these meshes as well. So, and if you're in the meshes, if you have these numbering, then something is wrong. So therefore we simply give that a name, because this is what we want to have, with the ceiling and with the column as well. We say that's 2. So now we can do whatever we want. We can go in and change the design. So we can discuss that, or we have different alternatives, whatever we want. So now we go here and we say scale 1.5. Now it's got a little conic, so we are happy with that. And now the same with this. Edit, and for example, go here, then scale it by 0.5, make this. Yeah, for example, we can switch off the column. Now we subdivide this selected field, subdivide it, and now take this element here and move it down a little. So, for example, like this. The problem now is that we have, oh, it's too much, I think, minus one, that we have a double curved face, so we have to triangulate that, which means we have to select this, and delete. You want to see what I'm... So we have to delete just the faces, and now we create new edges. So, and selecting all this, and putting faces in there. Now this is a refined thing. Maybe we can bevel the edge. So we have this, and no. So now we have the edge here, and now go for edges, say bevel, and these are the parameters: amount, a little, make it round, a little less, yes, sharper, less. Okay. Now we have a nice, more detailed element. So if we look at the column, this is the composition on the next level of detail, and this is a ceiling. This is a column. We don't want to change the materials for the next LOD. This will be later tutorials for more sophisticated layouts. It's just for giving you the fast idea. So if we have that, and then we simply can go to Mathematica. We have all this stuff. So, and we say it's a library, but we simply import LOD2 instead of LOD1. Now our problem is that we have the import here, and then we refer to them here. So you have to prevent you typing multiple times, especially here in the structure. Here it's a different game. So therefore I want to show you how to do that. We simply create new variables. We say column is copy, and then we go here. No, there's a ceiling. So ceiling is that. So therefore we can go and say ceiling, and we have it here as well. So then, evaluating this code, this variable is substituted by this string. So we do the same with the column. And say column is this. And then column is here. If we do that, if nothing is blue, then all this is, for example, if I'm having misspelling here, then this is blue, and then now you see, if you say ceiling, then he suggests, because he knows this variable, and then it's easier to control and to debug this code. Keep an overview. But now I have This is level of detail. This is exactly what we had. Now I can simply change it to level of detail 2. Evaluate that. Then I have this code. It's saved. And I can have a new startup and go for text. Open my library, the layout, and run that. Go back to the view, and here we see it's in detail. And it's organized in detail, as we had it. So that's pretty good. If you want to have another version, then simply go here and say this all keeps the same. This is my assembly. So we say, for example, take this out and say this is version layout 1, and is this. Hopefully it works, I don't know. At this layout, so now we can put in here layout 1. If we have that, you see it's the same. But now we have layout 1 and we can have layout 2 and make an alternative version. And for example, say we don't want to have the 4 here, we want to put that to 6 and have this here as well, or make a block 2 here, and give that 5, 6, 7, 8, and this is 2, 2, 2, 2. This is module B, but this needs to be imported. We need a code for that if you want to have that. Now we have a block. We say call that layout 2. If we now put this here layout 2, so we simply have this keeps constant. And then we go here in Blender, get a new document, and text editor, open our library, the layout, have that, run this script, and we have a problem here. We have module B, this is nonsense, we don't have it, I was too fast. So it's module A, it's here, A, floor 2, 2, 2, 2, and evaluate that, go to Blender again, make a new one, text, import, layout, run that, look for how it looks like, prototype, layer 1, layer 2, the other layout of the same system. So that's it, what I want to show, wanted to show in this tutorial. You see that your architectural design is neither structure, no, an architectural model is neither structure nor geometry, and code is something different. So, and therefore, all the talks about how to automate things, which is either parametrism, then you are in the geometry of things, or it's grammar, then you are in the structure of things. This is not code. With code, you're playing around with it. You're turning whatever you like. So it's structure and form. As, by the way, the internet is working with this XML standard, which is quite different from what we have in building information models. Building information models give you a predefined structure and then you parameterize the objects. So it's not a grammar. It's a geometrization of your architecture. So it's half of the game with BIM. And the other is with grammars. But I think with code, it's a language. And like XML and how like the all internet is working, it's a markup language, XML. So and this transports form and structure. So and this is what I shown you in our setup in Mathematica. By the way, you are able to do that in XML exactly the same way. Maybe I will find time to show you that. Thanks for watching. Hope you find it interesting and got your inspirations by that about thinking what architectural models are. Bye.